place. Um, and for those who don't know me, I'm Jenny. I'm the Director of Technical Resources. Shivani, do you want to introduce yourself really quickly?
Hey guys, I'm Shivani. I'm the Assistant Director of Technical Resources.
Yeah, and we will teach you about GitHub. Here are some disclaimers to start off with. Not everything we say may be like textbook accurate. So if we say something slightly wrong, you can totally correct us. But sometimes we did simplify a few things for like the sake of understanding, and so this everyone can get onboarded really quickly with the system. Number two, Git, there's a lot to Git that we don't cover. In this tutorial, it is no way expansive. And number three, this is just meant to give you a crash course of Git, and therefore it might not be as complete as it could have been.
And so, just want to add something, remind people one last time, really quickly. It's a very beginner tutorial. So if you feel confident with Git or you've done this before, you can stay if you want to talk to people, but you can also go if you also want to, and just do the assignment later. Just heads up.
Yeah, it would have been wonderful if you guys could have emailed me first, but it is okay. We forgive you. So the format of this is just going to be that I'm going to go over the PowerPoint so that everyone can just learn a really quick crash course about it. Shivani's going to do a demo, and then you guys are going to have to complete a partner exercise on your own time. And it shouldn't take more than 10 minutes if you've used the system before. If you haven't, that might take a little bit longer, but we're always here to help. Let's get started. So what even is Git? Git is a version control system. And basically, it's kind of like when you're editing an essay. Let's say you're writing an essay with two friends on Google Drive, and you realize that your friend deleted your introduction, right? Well, there's no need to panic because on Google Drive, you can track who made what edits when, and you could revert back to those edits, right? Now, I guess the creators of Git kind of thought of that, and they were like, wow, that'd be nice if we could have that for code. And therefore, Git was invented. So basically, it kind of stores snapshots of files or kind of the history of your code, and it has information on who edited the code, who contributed what to where at what time. Also, another very useful aspect of it is it makes collaboration super simple, which is why we are kind of forcing everyone this semester to host all of their projects on Git so that collaboration can be easy. Without Git, you'd be emailing files back and forth, and we decided that we do not want that. Let me try to, I drew up this very simple diagram for people who are kind of, actually, I'll do that later. Let's continue on. Okay, so I'm gonna just start by explaining a little bit about the difference between GitHub and Git. GitHub is the website or kind of the user interactive interface where you can view all your code. It's kind of the difference between YouTube, that would be GitHub, and the process of you uploading your videos, or a protocol between that. It's not a perfect analogy, but whatever gets you to kind of understand it, I guess. One useful thing you can do with GitHub is that you can clone repos. Repos are just mini projects, and basically when you would use this is if your project manager says, hey, let's say Aiden says, I wrote some LED code, he doesn't have to email everyone out. He could just point people to where the repo is, and everyone can clone the repo or just copy all the files down to their local computer where they can individually make edits. And kind of the workflow for that is you can use git clone, which means git copy, kind of, and then git pull is pull any updates. So if Aiden makes another update, you don't have to clone it again. You could just do git pull, and it should pull all your updates back. I will show more kind of interactive diagrams after this. So if it's confusing, do not fret. It is super confusing. And then, but what about you? Let's say you pulled all of Aiden's changes, but you want to be, a contributing member to your team. That's when you can make your changes and then add and commit them. So it's kind of let's say you edited the code to make the LEDs flash 3 times a minute or whatever. Then how do you get that up to GitHub, which is where it hosts all the repositories? That's where you add, commit, and push. You don't have to know too much about this, but basically adding is adding groceries to your shopping cart. Committing is you're checking out the groceries. You're committing to the changes. And then it's not on this page, but pushing is I guess you I don't know, you push the groceries out of the store into your car. You don't need to know the differences between them very extensively, but that's how you would kind of make sure that your changes get uploaded into the cloud where GitHub is, so that Aiden and other members of your team can access the changes that you just made. Let's see, what else? Well, let's not focus on that one. Okay, and push and pull. I also kind of touched on these briefly, but pushing is like, pushing your changes out, pushing them to the cloud so that whatever changes that you made on your computer, everyone else in your team can access. And then pulling is like making sure that you can access what everyone else did. So that may have been slightly confusing. I like drew a little graphic. Can you guys see my terrible pictures? Okay, cool. So this is, let's say this is the repo, okay? And this is you.
I don't think we can see your picture.
Oh, that's so unfortunate. Let's try again. Okay, can you see my picture now?
Yes.
Okay, it has like flowers on it. Okay, cool. Yeah, so sorry, this is your repo, this is you. This is you on your computer. And let's say that you drew a flower, but you want other members of your team to be able to see the flower. That's when you add, commit, and push. And when you do that, your local changes get uploaded onto the cloud, which is GitHub. Okay, let's go a little further. Now let's say that, I don't know, who's on the screen? HH, I've called you down. She is over here. She wants your flower too, but like you don't have to email her your changes anymore. All she has to do is git clone and pull the changes down to her local computer. Okay, cool. But now HH wants to do something, productive, and she draws a little sunflower on the side. Okay, that's cool, but how are you going to get that sunflower to HH to me? First of all, she's going to add, commit, and push her changes to GitHub, and then you're going to pull the changes, and everyone has the same version of the code. Now, this is like, a pretty dumb example with some ugly pictures I drew, but hopefully you guys can see how this would be really helpful for code especially, and in a remote setting. Also, another thing I want to touch on is like sometimes you can upload more than just code files. Sometimes you need to upload like, environment variables and things like that. And that's a great way, and GitHub's a great way, place to store those as well. Okay, back to the presentation. So hopefully you guys kind of understand the main workflow of that. Here, I'm actually take you to like a tour around GitHub. Let me show you. This is our organization, makers at USC. These are repositories, which are like projects. This is the one I made for us called Tutorial Practice. This is the repo. And then you can see there's a link that you can clone it. And there's some people who've already made changes to this so that everyone can have the changes. Okay, cool. Back to the presentation. Now, let's be more specific about how collaboration occurs on GitHub. And this is when branches come in. So basically, when you're collaborating on a code base, you don't want to mess up something that someone else did and then have it disappear in the stack of changes, right? So how can many people collaborate on the same project without messing up other people's work? Branches, that is the answer. So when you develop, basically you get to branch off of master. So if you see my mouse over here, this is master, and you can branch off of it. Just think of it like you made a copy of master, and then on the copy, you can make your changes, mess around, do whatever you need with it, and then merge it back in so that everyone can get the updated version of your code, but without messing up anyone else's progress. I hope that kind of makes sense. It's kind of like when you're editing an essay with a friend, like with 17 friends, you guys don't want to edit on the same file, right? Maybe you guys will all make copies in 17 different copies, all edit those, and then merge the changes later. It's kind of like that, except for Git automates it for us, so you don't have to manually make changes. Pull requests. Pull requests are needed when you're trying to merge the branch that you made back into the master version. So master should be pristine in that it should have beautiful, fully working code. It shouldn't have things that you're messing around with. It should have a fully well-developed version of your code. Let me see what other PMs in there. Oh, so let's say, this is Amin's project, right? And I don't know who's on, Shivani, for instance. Let's say she made a branch. She implemented a new feature that allowed,
Amin's project.
that allowed computer vision. But after she finished debugging and developing all of that, she wants to push it back into the master branch. That's when pull requests come in. I think the scenario I talked about over here is that if we're developing the Google search engine and I made the search bar and my teammates made the rest of the page, we want to integrate them cleanly without messing up each other's changes. And the way you do that is pull requests. GitHub is smart, and so they automate that for you as well. Yep, this is just a visual diagram. You branch, you make your changes, and you merge it back in. Cool. But I think the one last topic that we're going to talk about are merge conflicts, which is that which is when you're merging two versions of the same project back together, but you guys edited the same thing. So I think in this example, I used me and Shivani. Let's say we all start from version A from master. This is pristine. This is, I don't know, Aiden's light painting bot. Sorry, Aiden, you're on my screen right now. And then let's say I make a change to the function that detects the bot, for instance. And Shivani, there was a miscommunication, and Shivani accidentally implements the same thing, but slightly differently. Maybe I use some for loop and Shivani used some while loop. I don't know what could have happened. But when we try to merge them back together, Git gets confused because they're not intelligent, so they can't really tell which one is better. Do we want Jenny's changes? Do we want Shivani's changes? We don't know. And that's when merge conflicts occur. And it happens actually quite a lot. And we'll kind of show you really quickly how you can fix those so you don't have to get panicked like the first time that you work on it. Okay, quick summary. If you see over here, we have git add, git commit, git push. Those are you adding your files to the remote GitHub repository. You're making changes and then you're pushing them up. Git pull is you're bringing down changes that other people have made. Let's see. And then when you make git checkout -b branch name, you're creating a new branch and you're switching into that new branch. So you're making a copy and you're saying, I'm only going to edit this copy. I'm not going to edit anyone else's copy. And then git checkout just means check out to another branch, which means like, I want to go back to master now. I think I finished my feature. Git merge is when you're merging the commits from another branch into your current branch. And yeah, let's